Hi, good morning, good afternoon. I am Rob McCatherine, and I'm here to talk to you today about our 3D design updates in ANSYS 2020 R1. Feel free to leave any questions, and I will get to those at the end of the presentation. This presentation does have quite a few slides, so we'll have to go through this a little fast, but if you have any questions, just, again, pop them in. We'll get to them. All right. First, a bit about us. I work at PADT. We are Phoenix Analysis and Design Technologies. We are a ANSYS channel partner operating out of the Southwest, and we focus on sales, support, and services for ANSYS. We have about 85 employees. We've been around a little over 25 years. We're an elite channel partner. We do also offer technical support as well as consulting services for numerical simulation. And here's a little map of our coverage area. We offer award-winning technical support. We build strong relationships with our customers, and we offer a full physics capability, meaning we have expertise and coverage over every physics offering that ANSYS offers. And now a bit about ANSYS Cloud. ANSYS Cloud, as in the name, is a cloud-based service specifically addressing HPC needs of customers who may or may not have the required HPC, high-performance computing capabilities at home. It's a one-click burst to cloud, so you do your pre-processing on your computer and you send everything over to the cloud, and it solves it there. And from there, you can do your post-processing. So with this, it's again full access to HPC, so you can run larger, more complex models and provide more accurate simulations. You can evaluate more design variations. If you're doing a very large parameter study, you can run this via the cloud, and it'll come right back to you without you having to, upgrade your hardware to do so. If you're interested, feel free to contact our sales team, and we do offer a free 30-day evaluation of ANSYS Cloud. Our information is below, and feel free to contact us if you're interested. And now on to the show. All right, so we're going to start off with Discovery Live. Again, this is a lot of the broad overview of topics we're going to cover in this part of the presentation. So in general, we have improved the simulation of thin parts in Discovery Live, so being able to capture things like, say, for stiffened shells. We also offer a steady-state fluids analysis, so no longer just solely limited to just a transient analysis. You can do a very fast static solution with a steady-state flow. We offer a lot of improvements to topology optimization this update. We'll see those. There's a pretty extensive section on that. And then just some general improved rendering and graphical display improvements. And so here we can see our smart memory usage. So really this is just saying that you're using your GPU and your memory on your GPU to capture items based on that little slider that'll say speed or fidelity. So we're going to maximum fidelity. You can see last year, 2019 R3, and it's on the right side at the top. Turn it to max fidelity, didn't capture everything in this stiffened shell. That's not good enough for us, so we improved, and we now have the ability where we're capturing everything on this stiffened shell structure. And at a lower GPU cost. So previously, we're looking at a 16 gig GPU capturing not enough, and then an 8 gig capturing everything. Now, here's our bit for steady-state fluids. So on the left, you really just see the initial state of the transient solver versus the initial state of the steady state. It's really fast just because it's not transient. So we're just looking at the end of the solution. So if you're interested in a steady-state solution for your flow regime, it is now incorporated into Discovery Live. And here we're getting into the topology optimization improvements. So now you can combine multiple analyses with their constraints to offer a combined topology optimization. So really it's limited to static, structural, and modal at this time. So we see a static structural optimization on the top left and a modal optimization on the top right, and we've combined the two at the bottom. This is just another example showing, what you started with, initial material on the bottom right, and then the end result for topology optimization on the rest of it. So it's a nice little feature. I've played around with it a little bit. And now we're looking at manufacturing constraints, being able to control those as well. So, looking at things like what maximum thickness, or you're looking at, a draw axis, a two-sided draw, a draw direction. And you can then combine those. So you have looking at no constraints, which is just the topology optimization feature acting all on its own, versus having a goal of maximum thickness that you want to achieve, or just having a draw distance, and then being able to combine everything, combine all these considerations together. This is just another view of that same model on the previous slide. So here on the left you can see that it's no constraints, it's just kind of making webs on its own. Then we're looking at a goal for maximum thickness. Then we're looking at a draw axis, so it's just trying to get it that one pull direction to try and have an ease for manufacturing. And now we're looking at a draw plus a thickness at the very end. So throughout this whole process, we're working on combining our features together within Discovery Live and incorporating more features that are available throughout both the Discovery Suite and through ANSYS Mechanical here and there. So here we're looking at, with this optimization and like a resurfacing, we want to keep some boundary condition faces. So we're just outlining that, hey, it'll preserve those faces really well. It's not going to dig into those during the optimization process. And now we offer parameter studies with topology optimization. So what I've talked about before, you're available to create as parameters with those end goals, and you can then create larger parameter studies to find all sorts of fun shapes you can come up with. Now here's our deviation analysis. So this is a visualization of what that fidelity slider is actually doing. So when you're going through and you're in your Discovery Live and you're looking at your slider and choosing between speed and fidelity, this is showing you what's going on, behind the scenes. So you have your original geometry on your left, your lovely Skynet robot, and now you turned it up to 5% fidelity, and you can see that those red areas are areas where it's not fully capturing that geometry. And then at 80% fidelity, you can see we've captured pretty much all that geometry except for a few little ends here and there. But this gives you a visualization, whereas before it wasn't really there. It's still a beta feature, but it'll progress through in the next update as a regular feature, or the update or two. And now into the updates in Discovery AIM. So in general with AIM, a lot of the more physics is being included from Mechanical and the other suites. So, we're looking at hyperelastic materials, we're looking at orthotropic elasticity, we're looking at, including shell meshing enhancements that are available in Mechanical that are on AIM. We're looking at exposing mesh quality metrics, where AIM has included recently beam and shell modeling, but now because Mechanical exposed cable elements, those are now exposed within AIM as well. Now we have contact, where you can visualize disconnected bodies, more topology optimization features, again through the whole Discovery Suite. And then now we have a live to AIM enhancements, where we can transform more information from live to AIM in terms of your analysis settings, loads, boundary conditions, etc. So first off, we've got a Neo-Hookean Hyperelasticity. So we've got another hyperelasticity model. So if you're looking at doing seals, O-rings, bushings, etc., this would be a good idea for that. You can put an initial shear modulus and bulk modulus. And then at the bottom left, we see it's all specified within AIM via AIM's menus. Similarly, along with that, with these hyperelastic materials, just an example using a bellows. So you have a bellows using aluminum ribs, and here's the displacement, and then an equivalent elastic strain. And now we've included an orthotropic elasticity model. So if you're looking at stuff that's on lines of laminates or wood. All right. Oh, okay. I'm getting one question here saying the audio comes and goes. Yeah, just let me know if it goes out too much, and I will consider moving to a different phone. I opted not to go the headset this route because the headset the previous route was not giving good reception. So we'll do it this way. If anybody else says it cuts out too much, I'll switch to a different phone. No problem. All right. So we have an orthotropic elasticity model. Again, good for laminates. And now we have physics-aware meshing enhancements. So we have an automatic hex meshing enhancement. So you can, within your solution fidelity and within your mesher within AIM, toss that in so you're not just using default pets for everything. That way it can help you out creating a much more uniform mesh, and via this circuit board right here. All right, now we have some shell meshing enhancements as well. So we're detecting surface bodies and modifying mesh size controls based on this solution fidelity slider. So again, AIM operates kind of both ways. It's an in-between between Discovery Live and Mechanical in terms of it has that solution fidelity slider, but it also has exposure places where you can view your mesh settings, and we'll get into that here a little bit later. But this is really more for like shell and the new beam shell modelings as well. This is all taking more things from Mechanical, importing them into AIM, making AIM more robust. And again, here now we're looking at mesh diagnostics. So if you're looking for more detailed information, like aspect ratio, Jacobian ratio, quality, stuff that's in Mechanical, it's now viewable within AIM. And now we're getting on to the new truss and cable elements, well new to AIM. So these would be akin to the link and cable elements within Mechanical. So again, there's physics-aware meshing for beam elements. That includes truss and cables. So again, it's one element division per edge. These are really like tension compression only. Cables will be tension only. And you get a mesh and results display for these guys as well. So you can make fabricated structures with truss and cable elements. Here we're showing, a bridge, and we'll get another nice picture of this bridge model over here. So we have this cable-stayed bridge, and we can see that the cables are indeed doing their job to that road right there. And now, like in Mechanical, where you can display shell meshes with element thickness, we now have that in AIM as well. So it makes it much easier to visualize what's going on. It just brings that extra quality for Mechanical in. Now, as I mentioned earlier, you can view any disconnected contacts. So you can view like any unconstrained components. That way, by highlighting this stuff, you get a more rapid direction as to what you need to adjust within your model. Less guesswork for you and everybody. Now, as in Discovery Live, the manufacturing pull direction has been included within AIM as well. It does the exact same thing. You specify pull, it's going to act like you're pulling that out of the mold that way. And now we have some additional Live to AIM enhancements. Just generally, we've got, like I specified earlier, you'll be able to import various load cases within from Live to AIM now. So now you're able to do transient tabular boundary conditions, and again, with the steady state and fluids introduced, those steady state fluids are now can be copied directly over into AIM. So here we see someone defining a transient load. A transient heat flux loading, from Live, and then it goes right over to AIM. And now some lovely beta features. You can turn these on within AIM via this capability right here. Just go to Tools, Options, Appearance, and you'll be able to select that within the beta capabilities from there. And if you have any questions about that, feel free to consult the documentation. So now they're still working on some enhanced physics-aware meshing so we can more accurately capture boundary layers. So here we're looking at these flow regions, and we're looking at trying to capture this inlet right here. And the default, you're not capturing the boundary layers of the inlet, but because this is a beta feature, now we can allow for curvature and proximity. So now those boundary layers are preserved when we're meshing. All right, now the updates to SpaceClaim itself. So in general, there's more additive manufacturing improvements, which has kind of been the topic for this whole update. There's scripting improvements, and we now have a few more like SpaceClaim indirect meshing improvements. So being meshing through SpaceClaim, or just sending stuff to other physics, sending stuff to Workbench, sending stuff to Fluent, etc. We'll get into that here in a second. So right now we're looking at lattice improvements. So we've got two new minimal surface lattice types. And excuse me if I get the names wrong. So it's Neovius and Lindenoid. So we're looking at those for support structures or heat exchangers. And now there's a display for the length property for minimal surfaces. It correlates directly to one element of the lattice. There is a little scale. I don't know if you can see it here because the screen on BrightTalk's pretty small. But for you guys over here, the bottom right corner, there is a little scale on the sea of blue that says 20 millimeters as specified over here. So there's a visualization for it. And now we're looking at SpaceClaim's shrink wrap ability. So the default shrink wrap size factor was reduced by a factor of 4. So that way, we have 2019 R3 on top and 2020 R1 on bottom. So you can tell that we've made some major improvements to that. We are much more better at capturing the full extent of this geometry versus before you kind of got the general idea. There's much less need for user intervention by our improvements. And now we're looking at preserving open regions during autoskinning, so that you won't, the autoskinning process won't attempt to go over an open region, so that way you can have open and faceted bodies. That way you can combine analytic and patched regions and further downstream. So it's good for reverse engineering. You just maybe you just want to look at one particular region for autoskinning, and the rest you have. That way you don't need to bring everything in. And now we have simulation improvements. So now you can select round sizes. So bits of curvature are now selectable via the power selection, as you can see on the right. So you can specify, I'm looking at a rounds equal to or smaller than, whatever size, and it'll go through the whole model, select them all. It's a much easier way of selecting them. And additionally, we have beam attribute improvements. There's 2 new beam attributes for pipes and thermal fluids. So that'll help you out a lot with your thermal analyses. And now Truss was renamed to Link Truss for consistency. That's really just because you have a tension compression. When it goes over, you define it on the other end. But it's set to be that. You can set that within Discovery SpaceClaim. Now in scripting, we've exposed the ability to create selections from your boundary selections. So that way, if you have a topology source that's changing, you can keep track of it so you don't lose that. You can hide faces via the script. And now you can, I really like too, is thickness properties of surfaces. So in this, you can change, while you're in SpaceClaim, if you can assign thicknesses to SpaceClaim so it then ports that over to, let's say, mechanical. Now, instead, you can tie that in as the script, and you can keep track of that, and as well, you can assign the offset as well, so you can say, is it to a middle, top, or bottom? So you can really keep track of your thicknesses for your surfaces this way. There's been an improvement to the split tool as well, so now you can split multiple edges versus just a singular edge previously. So if you look at the images on the right-hand side, you can see that we've assigned, you want to split up this line into 5 segments. So previously, you just select one by one, or else it's just going to try and put everything that way. It's going to assume it's kind of like one line or just not work. So now, we've got it so you can have multiple different selections. It applies that rationale to each individual edge. We also have a data transfer and an export to PMDB option under the Fluent transfer. PMDB provides options to transfer data from SpaceClaim to solve on other platforms like Linux. And we have some additional Fluent improvements over here. That'll be talked about, I think it's this next slide or maybe a little bit later. Well, here we go. So now you can transfer mesh to Fluent directly from SpaceClaim. But there's a lot of options you have to go through here. Again, there's you can click it through the regular, kind of mechanical tab as you would send anything to, AIM, mechanical, workbench, etc. It's available there. And there's a SpaceClaim meshing Fluent connection in Workbench as well. So everything's becoming more interconnected. The goal is to be able to kind of, act as a very fluid and be a very fluid process of sending information to different parts of the ANSYS suite as you need to, how you need to. And again, along with the lines of that, there's new mesh export options. So you got other formats, you got regular ANSYS formats, CGNS, Celestina, Fluent, just available off the bat here. And geometry can also be transferred to Fluent meshing in additional formats as well. And with the SpaceClaim meshing, we're now looking at improving it so it incorporates boundary layers. So you're looking at, you can now do edge biasing based on height and ratio. So all this is just selecting a bias method from a drop-down list in SpaceClaim. Again, this is really critical for boundary layer, fluid near walls, analysis stuff. So with here, you can do this inside SpaceClaim now. Now push that over to Fluent. Now here we're looking at improvements to mapped mesh patterns. So previously we did it via decomposition, so it would create a lot more elements and nodes, and now it's available without decomposition, so you can conserve the number of elements. So to keep your simulations down should be needed. It can be defined prior to meshing on geometry faces or after meshing by converting to blocks. Now again, we've been adding some more scripting for basic operations. We're adding support for various different tools that you can see on the left. We're doing the add tool, delete tool, association tool, split tool, everything with blocking. So now meshing is being incorporated in the scripting as well. Scripting within SpaceClaim has been available over the past few years, so it's steadily being added on in terms of all the features within SpaceClaim are being able to be scripted. And that is increasing over time, and the goal is to have everything be able to be fully scripted within SpaceClaim. And so now we've got some improvements to quality metrics for fluids workflows. So we got some orthogonal quality. That's the default in the physics type set to fluids. But you can also choose like the Jacobian ratio. Same thing. It's mesh metrics. So those are available within SpaceClaim as well. We've exposed those for the fluids meshing. Now for some little miscellaneous improvements, we've got some auto-detect features for fluid solid cells based on presence of inlet outlets. We've improved mapped meshing. We've updated the TET mesher. We've got improved block visibility options. We have improvements to unstructured block meshing. Just various means of increasing robustness and usability within SpaceClaim now for the purposes of meshing, just making it a better mesh tool. I went through that pretty quick. That was pretty good. All right. If you have any questions now, just feel free to let us know. Or you can always follow up with us at info@padtinc.com. And with that, I'll be on the line for a few more minutes. And with that, thank you for attending. All right, it's been a few minutes. I'll take that as no further questions for now. Again, if you have any additional information or want additional information regarding the updates to Discovery Live or anything else regarding ANSYS, please feel free to contact us. Again, email is info@padtinc. And with that, everyone have a good day. Oh, wait, I see one. Here we go. Has Discovery Live added the ability to use contact? No, not yet. It's all bonded for now. So I don't know if that is in the future, but it's one of those things where if there's enough need for it, it could be. Really, that's more for an AIM issue. AIM has the kind of nonlinear contacts available as well. So if you want to be able to use different types of contact, AIM is your tool, or mechanical. All right. If that's it, then I'll go ahead and close the presentation. Again, feel free to email us, and everyone have a good day.